So let us move to the first presentation by Professor Karl Andersson. So Professor, welcome. So Professor Karl Andersson is from Luleå University of Technology, Sweden. He is associate professor. After his graduation with a PhD degree in mobile system at Luleå University of Technology in 2010, and serving as postdoc researcher at Columbia University in New York and National Institute of Information and Communication Technology in Tokyo, Japan, Karl is associate professor of Pervasive and mobile computing at Luleå University of Technology, Sweden. His research interest includes mobility management, wireless networks, and access network selection, among other related areas. He is a senior member of IEEE at ICN, and he serves as a member of the organization committee of LCN since 2014. He is serving on a number of TPCs and the editorial boards of Journal of Wireless Mobile Networks, Ubiquitous Computing, and Dependable Application, as well as Journal of Internet Services and Information Security. So the title of his talk is Multi-Connectivity and Energy Efficiency in Future 5G Ultra-Dense Deployment Scenarios. So welcome.
Thanks a lot. Maybe you can help me turn on the microphone. 1, 2, 3. 1, 2, 3. Matthias, can you hear me?
Yes.
Good. Thanks a lot for the kind introduction. Thanks a lot for inviting me as keynote speaker. I have given quite many talks during the years at LCN. This is my first keynote. Thanks a lot for coming this morning also. We were some guys having dinner a bit late, but I'm sure it's going to be nice. Well, I wanted just to introduce myself a little. We heard from the introduction who I am. My master's degree is from Royal Institute of Technology in kind of mid-Sweden. I worked in industry 12 years after doing my master's, mainly with Ericsson. I was also with Capgemini, a big IT consultancy in the middle of Sweden. Then in 2006, I moved to north of Sweden and pursuing my PhD, as we heard in the introduction. I've also been a postdoc here in US at the Columbia University in New York, together with Professor Henning Schultzrinne in his Team Internet Real-Time Laboratory. I also spent 2 months in Japan at NICT, National Institute for Information and Communications Technology. That was 2 years back. It was easy getting to LCN back in Sydney that year, I remember. Only 8 hours of flight from Tokyo. Some other guys had longer trips, I remember. And as we heard from the introduction, now I'm associate professor with my home university, Luleå University of Technology. Since this is the 40th anniversary of LCN, I wanted to kind of think a little about my own history of LCN. It is not as long as we heard the kind of old timers. My first LCN was here, not in Clearwater, but in Tampa, 2006. I was a very fresh PhD student presenting my first paper. It was a poster at the main conference, together with my main advisor, Krista. We had visited Sherbrooke before, seeing Sumaya. She's here. She's chairing the workshop I'm doing together with her in the other room. So it has been a nice journey together with the LCN team. And as we heard in the introduction, I'm also part of the organizing committee since 2 years back. Next year, I will be the publication chair. My friends in the organizing committee said that's one of the toughest jobs. I have to work with the proceedings, stamp all the papers and all that you don't see as authors. It's a lot of things going on behind the scenes. Yes. Back in 2006, I also remember it was me and Krista, my advisor. We were approaching Shung Tung Shen. He was the workshop chair by then. We were proposing another workshop, not P2MNET, but on Move. And it was a bit tough to get it through, I remember, but finally accepted, and the workshop is still going on. So that's a nice memory. I also just wanted to see how P2MNET was doing by then. It was the second event of P2MNET. Aserine was the chair also by then, and it was a lady, Mirela Notare from Brazil, was the other co-chair of this particular workshop. So it has been going on since 2005, so that's a long history for a workshop. That time it was 16 full papers at this workshop and 4 posters, but there was no keynote that I could call and kind of hear some information what a suitable keynote for P2MNET should be, so I had to do that in my own. 3 years back I was here presenting in another room, more or less at this exactly that time. I was giving a presentation on mobile e-services. That is a quite well-cited paper today. It's only 3 years back. There were also 2 very young attendees of LCN that year. Jens, I think you were here. Matthias, you were here. Do you remember these guys? It's my kids. It's Carolina, she was 11 by then, and my son Frederick, he was 8 by then. I argue they were the youngest ever attendees of LCN, I'm not sure, but I at least claim it. So they had the name tags, and you can see the big stripes also, and the chair by then, he offered them a free lunch in the restaurant just over here, so that is a very nice memory. I had a little Skype chat with them day before yesterday to show what I'm doing here, so they could immediately recognize the venue here, so that was nice. So this is kind of my personal LCN history, not as long as the old-timers, but still 9 years back I started. So today I'm going to introduce a little what we are doing in the very north of Europe, Luleå, our university, our research labs, and the partners we are working with. We are known to be fairly applied and to work very closely with industry. So I'm going to touch upon that before I go into the details of my talk, which is 5G multi-connectivity and energy efficiency. And then after that, I will touch upon the ongoing projects we have in mostly dedicated to smart cities, smart regions, where we are testing these 5G technologies that we are currently working with, so scenarios and projects. And then at the end, I will touch upon some upcoming workshops and also opportunities for something called open calls within one of our European projects. At least that could be of some interest to our European attendees here today. So Luleå is located very far north in Sweden. It's over 1 hour flight from Stockholm, which is the capital. Germany is kind of down there, and Denmark is to the left, and Norway and Finland. Our university has actually 5 campuses. Luleå is the main campus. I myself, I'm located in Skellefteå, which is a smaller campus with some 70 faculty staff members. We have around 500 students there. All in all, our university has 12,000 full-time students. And we have also a space campus in Kiruna, which is Sweden's most northern located city. It's known for its iron ore. And then P2, which is a music and arts campus, and then recently we got a campus in middle of Sweden also, which is also dedicated to iron ore research and education, Filipstad. We claim being well connected to Europe and also to US with quick flight connections, but it takes all this time to travel. But I could also add that we try to be very well connected in the European programs. I will show a slide on the projects we are doing right now, and also, of course, internationally outside Europe. Because even though quite far located, we really want to be kind of a player on the European arena and the global research and innovation arena. All in all, we have 19,000 students, but not all of them are full-time. So I would say 12,000 full-time students. We were founded back in 1971, mainly to supply North Sweden with competence in mechanical engineering, iron ore engineering, and our computer science department started back in early 80s. So that's our background. 1,600 employees. We have 69 research labs. I'm going to go back to this SES-related labs, and we're quite heavy on external funding. Within computer science, we have dependable communication and computing. We have pervasive and mobile computing, which is my lab, and the third one is information systems. We have also guys in the electronic side, embedded internet systems laboratory, signals and system with automatic control and signal processing, and then most notably the space guys located in Kiruna. 2 research labs, one dedicated to atmospheric science and the other on onboard space systems. We have so far 4 collaborative research centers. I spent half of my time at the Center for Distance Planning Technology, which is a joint research center together with Ericsson. Ericsson has some 700 full-time researchers globally. Biggest research lab is Kista outside Stockholm. Second biggest is Luleå, just next to our campus. So we work closely with them, and they are the only external partner in the Center for Distance Planning Technology. So we have quite a lot of projects together with them. I will get back to at least one of them. And the 5G research is also together with them. So the core of my talk is actually joint work with Ericsson. Then the process industry is very big in North Sweden. We have pulp and paper industry, the iron and ore and steel manufacturing, also sawmills and that stuff, and the energy side. So we have IT, R&D around it called Process IT Innovation. Then we have a center for long-term digital preservation and another one for space technology, obviously, since we are space campus. My lab, we focus on distributed systems and mobile networks, enabling mobility, ubiquity, and interactivity of not only computers, but also data, software, and users. We are some 12 faculty members, 2 guest professors, 2 postdocs, 8 PhD students, and 1 research engineer, as you can see. The targeted areas is obviously me, it's wireless systems, nowadays 5G research. You will hear also about me presenting smart cities and smart regions. Some of my colleagues, they do also energy efficiency, together with European partners and local utility companies, energy companies typically. I myself also work with data centers. I will return to that also, because it's really big in Luleå since a few years back. And I have 2 colleagues, or 3 I would say, working with games, gamification, that's really taking off in Europe nowadays also, and a few of my colleagues working in information security. So you will see later on smart cities and smart regions is basically about pushing content in a kind of a city environment through a wireless sensor networks and building applications on top of it. So the partners we are working with is obviously Ericsson, as I said. We also have Cisco on campus. That's a nice story. They acquired quite a small Swedish company called TailF recently, focusing on software-defined networks for data center networks and also kind of innovative network management solutions. That company has some 60, 70 employees. 7 of them are located on my campus. So that's the first time Cisco ever started R&D operations in Sweden. They have had marketing, sales, and support stuff and some education, but never R&D actually in Sweden. So this is the first time after the takeover of this company, TailF. We also have Ascom, which in North Sweden is a buyout from Ericsson. Ascom has been a keynote speaker not on this workshop but on Move. It was 2009 in Zurich. We had a lady from Ascom, actually from here in US, coming over and giving a keynote. They do network testing equipment, so we are working with them. I'll get back to that later. As I said, we work with energy efficiency, so the utility companies are very important. Skellefteå Kraft is the local utility company in my hometown. And then Ductus is a local IT company, just as Tieto, which is a Finnish-Swedish company. Then most notably we have also Facebook. Since 2012 they opened their first data center outside US in Luleå, just some 500 meters away from campus. It's a really big one. It's 350 meters long, 60, 70 meters broad. That's the first one. This year, just 1 month back, they opened the second data center just next to the first one. So they have now 2 data centers outside US, both of them located in Luleå, which is very interesting. Hydro 66, it's by far not as known as Facebook. It is a UK headquartered, London headquartered data center or co-location type of company. They are focusing on green IT and solutions for that. So there are quite many customers wanting to put their data in data centers or their service in data centers having a fully green touch. So what they have done is to build a data center totally in timber structures, wood, just next to the river or Luleå River. So they take the electricity right directly from the river They have no diesel aggregators because the grid is coming there with kind of 3 lines in. There is no cooling needed because the temperature in Boden is usually quite low. They have already winter up there. It's a bit far from Luleå even. In summertime it can be a bit warm a few days, but they typically have some shower equipment, kind of have. That's how they solve it. So it is a nice one. They just started 1 month ago. They have their first customers putting their service into their data centers. So data center is really a new thing to us in North Sweden also. This is inside of Facebook and Luleå. You can see on top. To the left is the building project, construction project, and to the lower right you can see the first data center they launched back in 2012. Hydro 66, it's kind of more small scale so far, but they will extend their operations and they have extension plans for the building. Yet another one is KNC Miner. They do Bitcoin mining and launched a data center just next to Hydro 66 in the town of Boden in an old military helicopter hangar. And they don't do any storage, they more do kind of offloading of calculations because these the encryption keys tend to grow longer and longer because of how the Bitcoin system is built up. So they sell Bitcoin mining machines, which is typically a normal PC, but it cannot handle the calculations. So it offloads itself to the data center in Boden, where the calculations continue, and then the parameters are sent back to the local client. And the calculations is going on in that helicopter hangar. They don't have any fancy stuff at all. They just have the kind of the big ports open if it is too hot. So then they have some fresh air coming in. That's how they do the ventilation. So it's fairly innovative and extremely easygoing solution. They have some birds inside, I've heard, and some leaves coming in at full time. So you can get some different types of data centers we have around. I will not go into these pilot projects we are doing, but because this is a 5G talk, I should not speak too much about the data centers. But I would like to mention also our partner 6, which is Swedish Institute for Computer Science. I would translate it into Fraunhofer Focus, speaking kind of German, or India if you were in France or so. They are right now installing a 2 megawatt infrastructure and cloud data center test environment. So as a researcher, you could come there and really try out your solutions, either all the way up from how the racks are installed and how the electricity is coming in and how the ventilation is done, or more kind of to see how your cloud-based solutions are working. So that is an ongoing initiative right now. This is the portfolio of projects we are pursuing right now. Most of them are Framework Program 7, FP7 projects, or Horizon 2020 in the European arena. A few of them are national projects. But as you can see, we really try hard to be on the European research and innovation arena, because even though far away located from kind of the center of Europe, we really want to be in those projects. This is kind of the partner map we have. I guess you can't see all the names, but it's both other universities, it is companies, it is towns and cities, and different types of organizations. But I won't go into that. Coming over then to 5G, which is the core of my talk. First, kind of talking a little about the 5G requirements. When the vendors and the operators and also end user organizations, they are talking about 5G, what are they exactly talking about? Well, from a network perspective, there should be obviously low power consumption, and that's the project we are now doing with Ericsson centered around. There should also be cost efficiency, both for the kind of the old timers, but I will also get back a little to 5G in not only rural areas, but also developing countries. I have a project with Bangladesh where this comes very timely. There should be flexibility for future evolution. Nobody believes that 5G is kind of the final solution. We have had a long-term evolution from NMT back in Scandinavia, Nordic mobile telephony, which was kind of an old analog system. Then GSM came, 3G, 4G. We have now LTE advanced, and then 5G, but nobody believes it's going to be the last one. So there needs to be kind of flexibility for future evolution also, obviously. Many people have talked about fixed mobile convergence, but I mean that has been until now more kind of a buzzword. For 5G, it should really be thought of, kind of built into the design of the architecture and that style. There should also ultimately be an integration of the 3GPP standards, the 3GPP accesses and the non-3GPP accesses. That has also been kind of around for some time, but now it's really coming. There should be obviously be resilience and robustness. I said I was in Japan and they had a big earthquake 3 years ago, and I know they do a lot of research around kind of resilient and robust networks, so the base stations and they should at least work in kind of a more local or proximity way. It should not be any central entity controlling everything. Obviously, higher capacity, everybody wants broadband, kind of 50 megabits or all over that. There should be even higher spectrum efficiency. I've done some background studies and I saw here for US the spectrum is more or less finished in a year or two if we continue the way we're doing now. There should be ease of deployment and operation. This is a big issue to the big operators. If 5G could solve that, it would be good. There should also be a control of the EMF exposure levels, because sometimes that is a problem with today's solutions. There should be both high down and very low bit rates. Typically in the projects I will talk about later on is we send sensor data, very small amounts of data. The bit rates can be very low, but then the target should be energy efficiency. But then on the other hand, there should be also low latency applications, also with high bandwidth or high throughputs. So 5G should ultimately support both. And spectrum agility. Different countries typically allocate different pieces of the spectrum to mobile operators. In my home country, there was a big shift from TV over to 4G and 5G recently, maybe in the rest of Europe also. Then here in the States, the situation is somewhat different. So if there could be a kind of a agnostic view on the spectrum uses, then 5G solves many problems also. Taking the kind of the more user experience or the user side of this, there should be a homogeneous experience of the coverage area from static to high-speed trains, velocity. I remember the GSM specifications had also high-speed trains as kind of the target for the mobility. And then there should be both outdoor and deep indoor coverage, which is not always the case today. Of course, high typical throughput per user application, end-to-end latency down to a few milliseconds. We are doing some fancy projects around automatic control of equipment in mines and that stuff, and then you cannot sit in the control room and wait before the network is sending the commands to if it is a drill or something beneath. Connectivity transparency, there should be experience optimization on a per customer basis. Typically there should be kind of one backhaul and then a lot of network slices and different networks for different applications. That's how it's going to be working. And obviously there's going to be a lot of new opportunities for us as researchers, but also companies with a lot of IoT type of applications running on top of 5G. Also vehicle networking, which is the topic of the other workshop, which I'm usually working with, and also ultra cost networks that I said. Here is let me see here, going back and forth a little bit. The idea here is to have 5G enabled to, as I said, developing countries, really low cost solutions. And the idea here is to extend the macro coverage solution and have a simplified architecture networks and a bit kind of relaxation of the network constraints. If you could have a solution which is really cheap, you could perhaps allow for a bit lower availability or performance, low cost network operations, adapted the IPR framework or the RF design, self-healing optimization, configuration, and also low cost backward solutions. I'm thinking of what Facebook and a few others are doing in terms of their Internet.org projects.
they have done some surveys and seen that 4G is not available in too many areas in the world, and perhaps we will see what 5G is doing. But they are now shooting up satellites with laser communication and that stuff. We had a guest lecture from Facebook at my university a few weeks back. But this is kind of the promise from 5G in terms of low-cost networks. So let me go back here then. So what we are doing now is just starting a project together with Ericsson. This is myself and a student of mine doing this work. And the idea here is to work with ultra-dense deployment scenarios where base stations are extremely dense in an area to support high rates and also offloading and most notably more multi-connectivity. So the mobile station or user equipment here is not only communicating with one base station or node B or eNode B as it's referred to in 4G, but many at the same time. So we do this both for performance and also robustness reasons for kind of diversity, having frequency diversity and space diversity. And the idea here also is to steer, can you hear me? Yeah. Is it a problem? No? Good. To actually steer the traffic to certain base stations or eNodeBs at a certain time, and then actually you have also base stations going into sleep mode. So we are currently working on algorithms for that and try to optimize it. It's me and my student working on that. And we are also investigating the performance for multi-connectivity system in this kind of ultra-dense deployment scenario. So we are now developing smart energy efficiency algorithms and still having it under kind of a very high robustness solution because the cellular networks are kind of known for having a high robustness level. So we are combining measurements from different mobile phones out in the area with network data studying to improve the self-organizing networks. So this should be kind of done in a totally automatic way and also taking in a lot of data from handsets spread around. And the other functions that need to have kind of this heterogeneous network deployment scenario with the existing radio access technologies and also new RITs coming, and also for having Wi-Fi accesses as a kind of complementary radio access technology. We are correlating massive data collection from different nodes, and we are also looking into machine learning. I'm not a machine learning expert myself, but my colleagues are, and one guy we are working with at Ericsson, he's looking into this to really optimize the learning here over time also, because this will be a very varying situation with a lot of nodes coming in, and the our radio climate, so to speak, will vary over time. We are right now simulating this in not the standard NS2 or 3 or OpNet or so that most of you are working with, but an in-house developed network simulator within Ericsson. And on top of that, we are planning to set up a test network. We have been discussing with Ascom, the other company, because they have that kind of in a basement in their lab. So we can do that without having a real license working out in the geography. So the ideas around energy efficiency is that we will improve it with traffic growth, because traffic growth is really huge, not only here in the developed world, but in the kind of third the developing countries. It's a huge growth in terms of traffic, but then also in the storage volumes are going up a lot because of people taking a lot of photos, and also sensor traffic is going up. Hardware improvements, load dependent base stations, and so on, we will take into account. Reducing transmit power to a few watts per sector is another factor that we are looking into. Inter-site distance is being optimized, number of small cells also. And as I said, sleep modes, not only for the mobiles or user equipments, but for the base stations. We're also looking a bit into an optical backhaul technologies, how that can be done. Ultra low, I already talked about. So now I'm going over to speak a little about the projects we have where these new 5G technologies will be tested. This is an ongoing project I have together with a university in Bangladesh. It is funded by the Swedish Research Council. It's a 3-year project starting this year. So the project is about predicting flood, which is a very big problem in Bangladesh. I was there this July and half of the country was flooded by then. It was not a problem, my colleague said, but it's typically what's happening. In Sweden we don't have too much flooding, but it's kind of an issue coming up. I know security around dams and that stuff needs to be maintained better. I know in Central Europe there's some flooding going on from time to time. So this is kind of an issue coming to more and more areas. So the idea here is to gather data in a lot of sensors deployed typically in a river valley or so, and then over wireless sensor networks, working both with Zigbee and Wi-Fi we have, and then the new 5G technologies that I spoke about. We are building up kind of a big system. Here is the risk assessment model we have been developing. This is my colleague in Bangladesh that developed this. It is, I think I will go on here. The old application he had is a kind of an old style thing he developed in Bangladesh. We have now made a new version. But here is the kind of the decision trees where the factors go in, and it's a multi-level tree with different factors affecting the overall result, which is ultimately the level of a river in our configuration. So this is the system architecture we're working with, and the 5G stuff I was talking about will be kind of in the middle there. Together with Wi-Fi, we have also wired LAN and Zigbee, as I said. We are deploying the sensors in the river valley. We have the gateway solution, and we are reusing an old smart city platform that we developed a few years back. And the new thing here is the web-based, rule-based expert system in the middle there, and the kind of automatic fetching of data and spreading of data in the wireless sensor network, where 5G is one of many bearers. So we are using standard Arduino hardware with the wireless module and also the P2MNET module, cellular and Zigbee, and so far we measure temperature, humidity, soil moisture, rainfall, and water level is kind of the output there. And we do deployments both in my hometown, Skellefteå, and in a small river called Bakale in Bangladesh. I've been there once this July. So this is kind of the background of the belief rule-based expert system, which is kind of this background comes from Bangladesh. So it is, we are building on the existing system there. So the input is coming from the left, and then our expert system is working in the middle, and then typically the outpost is coming there, which, as I said, in our case is the river, the water level in the river. We have recently made a newer version of this, a web-based, belief rule-based expert system, and it looks like this. I'm not sure you can see exactly. It is more or less a kind of a port from the old Windows XP-based system, but kind of in a more newer fashion, and it now takes automatically some data from the sensors, but we're still in the early phase, and the 5D technologies I spoke about, that is just simulated so far. So it's a mixture of experimental environment and simulation. We are connecting this to the existing SenseSmart City, SenseSmart Region platform. So here is a sensor for humidity that we have connected. This is my PhD student doing some hacks. This is all the time the measurements he's doing. So it's typically being measured every 15 minutes or so, sending data through this platform, and then it goes into this web-based, belief rule-based expert system, and taking all the other values into account, and then computing this water level in the river. So this is what my student is working on.
Excuse me?
Yes?
The water level is estimation, or this is something that you actually measure?
Yeah, it is the estimation here, but then we have kind of the real value also, so we can make a kind of a feedback loop. So it is obviously both. Actually, we work together with Skellefteå, which is the utility company, and it's them also kind of steering the water levels in my hometown at least. Then if it is kind of freely floating water river, then the case is different. But in my hometown, it is a regulated river, so there we have connections to the hydropower company, so we speak to them and we can actually get to know how close we are to the estimation, how good it is actually. So it is both. Mm-hmm. This is another project which we just started. Yes?
Can I ask another question?
Mm-hmm. Absolutely.
It's about, what are the type of, so suppose that you see that you are expecting a flood. What are the means that you can do in order to eliminate, to avoid it, or to reduce the impact, or do something? What are the, I assume that actually you have dam, and is that?
Maybe that's a bit out of scope, but I know for Bangladesh I can't tell. I've only been there once. But for Sweden, I know there are actually plans for moving the whole city of Luleå outside Luleå, and they will come to other towns. So it's actually from the municipality side there are concrete plans where to put people. There are pre-ordered buses and that stuff. So there are plans in my home country.
So there's
Evacuation plans.
But you don't have any means in order to somehow divert the water, or to actually gradually release some water to something like that.
I can tell you the rivers that have hydropower stations installed today kind of try to work with the dams all the time to have open or closed doors, so they do it all the time. But in Sweden we have 4 rivers that are protected by law, which we cannot install hydropower to. It is the border river to Finland, Torne River. There are no hydropower stations at all, and then 3 others. There we have, from time to time, big problems because there's no way to steer the flow or so. So there, these evacuation plans could come into play sooner or later. But that's a bit out of scope. This is more kind of a technical presentation. So it's Organic City is a newly started EU project, Horizon 2020. Where I hope to have our 5G solutions also tried out, because this project is using our sensor platform. It is a project, a fairly big one, 7.2 million euros in EU contribution, managed from Aarhus, a Danish city, where it's basically 3 cities in Europe collaborating, building a new common testbed, and also kind of a co-creation platform for end users, citizens of many cities of Europe having the possibility to build end user applications, not always being programming capable or computer science educated, but kind of end users having I would say a kind of a graphical design where they kind of build their applications and publish on the web. So it is Aarhus, as I said, in Denmark, then it is London, City of London in UK, and Santander, Spain. They are well known for their activities in terms of smart cities. I would say they are the leader in Europe. So our role is, we try to push Luleå in to be a smart city also, but it's kind of tough. So we have a bit, how should I say it, a bit minor role in this project. We are working with open calls that I'm coming back to, which is important. And then also with the platform to some extent, but we are not kind of a targeted city. It is Aarhus, Denmark, London, UK, and Santander, Spain. But it is a kind of a flagship project, I would say, in Europe, the leading smart city project right now. And as I said, the idea is to play as an interaction between everyone, all citizens in the city, researchers, activists, citizens, businesses, city governments, municipalities. Everyone should be able to contribute in this platform, building their own applications. This project is giving or organizing workshops, meetups, conferences, and events. We were at the ICT 2015 event last week in Lisbon. 7,000 people were there gathering to see new innovations in R&D in Europe. But we have other events also. So the idea is to kind of provide a platform for end users accessing these smart city environments that I've been talking about. And to work more kind of on the soft side with co-creation, enabling these technologies to end users to a way higher level than we have been used to. And the first kind of iteration is to work with Aarhus, the Aarhus cluster in Denmark. So there has been some innovation, some I would call it challenges or so. So that is so far what has been going on. And there is an opportunity for other people to join this project and even get some funding. I will get back to that at the end. So these are the mature smart cities that are in. Good, this is working. I was a bit afraid the appearance here would be screwed. So the SenseSmart region is a newly started project we have also, together with the Bangladesh project I talked about here also, where we are testing our 5G technology. This is building on a previous project for SenseSmart cities, where the idea is to gather a lot of sensor data in a city environment, but also do it in rural areas. North Sweden is obviously fairly kind of rural. It's very sparsely populated. The towns are medium-sized, but the outskirt areas outside the towns are very small villages. So this project is taking these technologies also to rural areas, and there 5G comes into a very important access technology. Also, not only sensor data, there will also be open data. Linked open data is kind of a big thing, at least in Europe, I believe here also in US, where typically government agencies, also some central government data should, to the highest possible extent, be open, if it is kind of more sensitive or so. And end users, businesses should be able to create innovative applications based on that open data. So this platform is being extended for that. And one student is also working on kind of augmented reality based on this open CV. That is not really my area, but that's kind of more visualizing, doing visualizations of the data, kind of 3D models, and we are working together with Google there and their glasses. So this is the kind of how the gateway is built up, the inner structure. I won't go through all the details. And the API server, I think it's not the details there. You can look at another time. What is more interesting to me and my student is the performance benchmarking we are doing here, the mobility to cloud solution. So we are taking some old results that I worked with as a PhD student myself, and we are setting up an environment where we are benchmarking and seeing where the mobile nodes could connect different to the servers. So this is kind of some building on old results, but taking to this new SenseSmart region context and also with a more cloud-oriented backbone. So we have some initial results here. It is our postdoc that has been working with this, and he did 2 types of experiments. One was to compare local clouds with public clouds, having local clouds typically either in the mobile nodes itself or in the base station or near to the access points, or to have a public cloud typically like Amazon or Google or the others, Microsoft Azure. The other experiment he was doing was to see how we could do both cloud and network selection in a kind of a smart way. So I know some people here do that type of research, also trying to find the best connection network-wise, but here also we are taking it to kind of a multi-cloud environment, multi-public cloud environment. So we measure not only the different access networks around, but also the performances of the different cloud operators that might be around in the vicinity of the end user. So this is very new results. There is, we have some previous results and selected publications that you can dig into. Some have been published here at LCN previous years. Some stuff is to appear in a few months or so. So I'm just about to wrap up to run into my own workshop. Next year, on Move, we'll target more of this, the other workshop. So feel free to submit there. I will work together with Sumaya next year also. Also, I'm doing a similar type of workshop at Infocom being held in San Francisco next April, focusing more targeted on mobility management in future networks. So I'm co-chairing that with a researcher from South Korea. deadline is around the year shift, end of December or beginning of January. As I said also in the beginning of my talk, or in the middle of my talk, this Organicity, a European funded project, has openings for overall calls. And that means that a significant part of the overall budget is targeted not only to us, which are already on the consortium, but new members that have innovative ideas of typically sensor applications, maybe more end-user oriented. You can apply actually to my university, LTU. We are the administrators of that part of the Organicity project. And as I understood it from my project manager there, the call will open early next year, and the deadline will be around March or so. So that could be something for you. This is my contact information. I will be around here today, but in the other workshop. And definitely I will be in Dubai next November. So thanks a lot. I believe there are room for questions.
Yeah.
We had a few already, but please feel free to ask more questions, what we are doing in Luleå. In 5G or the other areas I also spoke about. As I said, clouds and data center is really booming. So we are looking how to combine that with the 5G research we are doing. And as you heard, smart cities is something that we are really targeting nowadays also. Tobias?
Yes, so maybe in the first part we talked about switching on and off the networks, and also on machine learning. So are you going to use this collaboratively for switching on and off the networks, changing cells and over users, and so on, everything in one single program together?
Yes.
What
Yeah. That is the idea. We don't, as you heard, we don't have any results published yet, so this is fairly new. The student more or less just started, and the Ericsson researcher. But the idea is what you're telling, to base on the historical data, see patterns when there's kind of an opportunity of letting base stations go into sleep mode, and to base it on previous data using machine learning techniques. But that as you heard, it's still kind of being investigated. Hopefully I can report something on MOVE or LCN next year or so. More questions, ideas? Tobias, you're keen?
Yes.
Good?
Yes, another one. What do you think when 5G is from device communication?
That is an emerging area, because I mean there's also a way of offloading the network itself, and not quite often I would say people tend to communicate with the guy sitting next to him or her, or also from this resilience perspective that I talked about, it's really good if devices can connect directly. So in the 3GPP specifications there are work going on in that area, and I know Ericsson, my colleagues there from Luleå, are looking into that. We are not targeting it here directly, but I can see your point that it's making the whole optimization and energy efficiency taken care of, also taking into consideration device-to-device direct communication. That is a good idea. We have it kind of on our bullet list, but in the current setting we are not doing that, but it's a good idea, absolutely. And it will be there for ultimately in the kind of the specifications also. So good. People are a bit tired morning time. One question there, good.
Yes, you think that 5G requirements are reachable by 2020?
Oh, yeah. The question is if I believe the 5G requirements are reachable by 2020. You're from Orange, are you? Yeah. I've looked into some material, and we have some connections, as I mentioned to you yesterday, actually in France. I believe what the kind of common sense is that it's maybe not by 2020, but during the 2020s with an S at the end, so during that decade. So I would believe it's a bit beyond 2020, but maybe your company knows more than me. And Ericsson, for sure, they know stuff, but they don't tell everything to me. I would be glad to see. Good. obviously there are many problems they try to solve it with the same standards. So I would be surprised if everything that I had on my slide there in the middle will be there. So good. People are tired, want to have coffee or so. Perfect. So thanks a lot.
Thank you so much. Before we finish, as a recognition for his effort and for his involvement in the community, we just a small certificate.
Yes.
For,
Thanks.
thank you.
So now we do
Picture, Matthias.
both
Yes.
cameras.
Good. Thank you.
Another one?
Yes.
Okay.
I remember I handed over one to Salil the other year.
Okay.
Okay.
Thank you.
Perfect. Thanks a lot.
Thank you.
I will now go to the other one.